to show you a really cool problem here. We're going to have 3 parentheses x positive 2 equals 0. Now this problem is going to give us an opportunity to talk about loads of concepts just in this one little problem. So at the top of the page it'll say something like simplify. Well, it's already done, right? Well, wrong. We have a variable term, and we talked about what a variable term is. We talked about what constant terms are. Constant terms are number, variable terms are letters. We need to get that variable term all by itself on one side of the equal sign. In order to do that, we're going to have to eliminate some numbers. Just remember though, as you do something to one side of the equal sign, in order to maintain that truthfulness of that statement, we have to do to the other side. So if we take something off here, we have to take something off here, kind of a thing, right? It has to be the same. X and positive 2 can't really be combined because one is a variable term, one is a constant term, and in terms of adding them together, we can't really add anything. We can't simplify it any further than it already is. So if we understand the commutative nature of multiplication, we can see that there's a distributive property here that we can apply. So in other words, everything in parentheses tree is one value. So 3 is going to have to be multiplied against everything in it. So this becomes 3 times x. Now 3 is the coefficient for x because that says 3 times x right here, right? So the coefficient is the constant term that's attached to the variable term through multiplication. So we've just learned another thing just in this one little problem. Now we're going to multiply against positive 2. 3 multiplied by positive 2 is going to be positive 6 equals 0. Now in terms of what you do to one side, you have to do to the other. We haven't done anything to this side in terms of taking away or adding some values over here. We've just combined like terms as much as possible. We don't need to do anything more over here per what we've done thus far. However, we want to get that variable term all by itself, that x, and in order to do that, I need to get that 6 out of there. That 6 is a positive 6, so if I have 0,
1, 2, 3, 4, 5, and then 6.
I'm at positive 6. I need to get it to 0, so I need to go in the negative direction 6 places. So I'm going to go negative 6, and that will give me 0, and we can see obviously why that would bring it to 0. Now we have 3x equals 0. We know that can't be right because 3x plus 6 equals 0. Therefore 3x alone cannot equal 0. Not for this problem, right? Because x has a set value for this particular problem based off the original statement. So whatever I did over here, I need to do over here in terms of taking away or adding to. So I took away. So this is going to be negative 6. 3x equals negative 6. That is a true statement. Erase that. Write it a little neater. 3x equals negative 6. Now we still haven't technically solved for x yet. X has still an unknown value. So what can we do? Well, we have 3x equals negative 6. I can get this 3 or this coefficient away from x by dividing. And that will cancel out the 3. And then I would just divide over here. But before we go any further, let's talk about why that works. Well, 3x, which is the numerator in this case, right, on top of the fraction, is equal to 3x over 1, right? This right here is equal to 3x over 1. So this really says 3x over 1 over 3 over 1, because 3 is the same as 3 over 1. And the reason it's the same is because 1 is the identity, is the multiplicative identity. So when we multiply or divide by 1, we let the other number keep its identity. Just like 0 is the additive identity. If we add by 0, it keeps its identity. So 3x is the same as 3x over 1. This is a division sign, so we'll put a division sign right here. This is the same as 3 over 1, so we put 3 over 1. Now, when we divide fractions, we just switch to multiplication, flip the second fraction, multiply straight across. So we end up with 3x over 1 multiplied by 1 over 3, which we just said that 1 is the multiplicative identity. So 3x times 1 is what? 3x. 1 times 3 is going to be 3. So we end up with 3x over 3, which is what we were saying right here, how we would cross cancel that. Because 3 over 3 is the same as imagining a pie cut into 3 even slices. The slices represent the denominator. The amount of slices we have can represent the numerator. If I have all 3 of 3, I have how many pie? I have a whole pi. 1 whole pi. Therefore 3 divided by 3 is 1. We just said that 1 is the multiplicative identity, so 1 times x is just x. So we got x by itself. X is equal to negative 6 divided by 3. So now we have negative 6 divided by 3, which is equal to a negative divided by a positive is going to give us a negative, so we're going to get negative 2. Now we can plug that negative 2. This is the really great part about algebra, is we can take the value of x and we can plug it into the original formula and see if the statement is true or not. 3 parentheses negative 2 positive 2 close parentheses equals 0. So let's see if that's a true statement or not. Negative 2 positive 2. Well, what does that mean? It means we're at 0, and we go negative 1, negative 2, and that's where we're at. That's where we start. This tells us what direction on the number line we're moving. This tells us how many places. So we're going to move towards the positive 2 places. 1, 2. That gives us 0. So this is 0. So we have 0 in parentheses. 3 is the coefficient to the parentheses, right? So that means 3 times 0 equals 0. That is a true statement. And we're able to learn a lot of different concepts all at the same time, just doing such a simple little algebra problem. So you want to practice loads of problems like that and just really get a handle on why the numbers are able to be isolated, manipulated, and variables are able to be derived and isolated the way that they are. Alright, cheers.